Over the last course lectures, you learned all the core basics you need to build amazing Flutter apps, and actually already a bit more than just the basics. After all, we had a look at responsiveness and writing adaptive applications. So that is all super important and gives you a solid set of skills to build Flutter apps. In this module here, we'll dive a bit deeper into Flutter, have a look at some behind the scenes stuff, like for example, how exactly it rebuilds the user interface and what you can do in your code to make that more efficient. And we'll also have a look at a couple of other advanced features or niche features which we need in Flutter apps from time to time. In detail, just as I said, we'll have a look at some of the under the hood stuff Flutter does, which is of course not directly important for you because you don't have to, well, manage that under the hood stuff yourselves, but it's A, always good to know how the tool you're using works, and B, as you will learn, there are some things you can and should maybe think about when writing code because you can then improve the way your app works and, most importantly, improve the performance of your application. That's the transition to the second block or the second important concept or topic we'll have a look at in this section, writing good Flutter code. We'll explore what good code means and then what you can do to improve your code quality and make sure that your app runs good and runs performant, but also that your code is readable and maintainable. And last but not least, throughout this module, we'll also have a look at a couple of advanced Flutter and Dart features. Advanced not really in the sense of super difficult to use, but niche or not always required, but good to know and good to be able to use to improve your apps and to really understand what's happening in your apps. So this is a very important module as it will take you from I know how to write a basic Flutter app to I know what Flutter does and I can now use that to write more advanced apps. Of course, it's by no means the end of the course. We'll have a look at a lot of other core Flutter features, but this is now another important step in your journey to becoming a Flutter developer. Now, for this module, I'll again come back to this personal expenses planner we wrote over the last course sections. We'll not add any new features to this application, but we'll use it as a dummy or as an application to explore a couple of under the hood things and a couple of advanced things, as I mentioned in the introduction to this module. And the thing I want to start with is how Flutter actually draws the content you're seeing here on the screen and what it really means when I said that Flutter executes the build method. Because as you probably already noticed and as I already mentioned, build gets executed relatively often and every widget in our application has a build method. So does this mean that whenever build runs, Flutter actually redraws the entire screen and therefore running build is actually bad? Because as you can imagine, whenever Flutter has to really redraw the screen and redraw the pixels on the screen and rebuild all your widgets, your elements, that sounds like a performance impact. And actually it would be. The good thing is Flutter doesn't redraw or recreate the entire UI on every build call, but let's simply have a look at what Flutter really does. The first important thing to realize is that Flutter aims to give you a 60 FPS application, so it updates the screen 60 times per second. And that of course means that it does indeed redraw the pixels 60 times per second. Now this, however, is not bad. That's how all apps and all games that run at 60 FPS or more work. And of course also for lower FPS rates. In the end, the FPS measure really just means frames per second, and that means that the screen or what you see on the screen is repainted X amount of times per second. So in a 60 FPS application, that means 60 times per second. Now this would only then become inefficient if Flutter would have to recalculate the entire layout here 60 times per second. Because when Flutter draws something onto the screen, it of course, for the first time, when it draws it for the first time, it needs to figure out the position of every element, the color of every element, the text of every element. So it needs to configure every single pixel on the screen. For subsequent draws, so for refreshes of the user interface, if nothing changed, Flutter takes the old information it already derived and paints that on the screen, which is super fast and very efficient. So the refresh rate itself is not a problem. It would only be a problem if Flutter would have to recalculate everything on the screen with every refresh. And now that of course leads to the question, is that what's happening when build is called? Does that mean that Flutter does have to rebuild, recalculate this element and all its child elements? For this, let's dig a bit deeper and understand what build really does. It's important to understand that Flutter indeed does not just have the widget tree, which I mentioned over and over again already, but that it has a second and even a third tree, the element tree and another tree. So the widget tree is what you already learned about, but as I just mentioned, there also is an element tree, and there even is a third tree, a render tree. Now, you, with your code, you control the widget tree. The other two trees are controlled internally by Flutter, but they are based on your widget tree. The widget tree which you're creating with your code and which is built by Flutter by calling the build method is essentially just a bunch of configuration Flutter takes into account. It's not directly output on the screen or anything like that. Instead, it simply describes to Flutter what should be output on the screen. So it's just a bunch of configuration settings, you could say. The element tree then is important because the element tree is created by Flutter automatically based on your widget tree, and it links your widgets to the actual rendered objects. Now, where the widget tree is constantly changing, basically whenever you call setState, for example. So whenever the build methods get executed, Flutter rebuilds that widget tree. Whilst that happens relatively often, the element tree is managed differently and does not rebuild with every call to the build method. And it links the widgets, the configuration you set up, with the actually rendered elements, which are part of the render tree. So the render tree, in the end, you could say, is the representation of what really ends up on the screen, what you see on the screen. And that also is rarely rebuilt. Now let's have a more concrete example. This is our widget tree. We have a container, and in the container we have a column, and in there we have a stateless and a stateful custom widget, which of course in turn then have other Flutter widgets in them, like text widgets and so on. Now, for every widget you have in the widget tree, Flutter automatically creates an element. It does so when it first encounters that widget. So for example, when the app starts, or if you have an if condition and some condition is now true, and that means that now a new widget should be rendered, which hasn't been rendered before. Whenever Flutter encounters a widget for which it has no element yet, it creates an element. So an element in the end is just an object, you could say, managed in memory by Flutter, which holds a reference at its widget. The element itself has no internal configuration. It really just points at the widget, which then holds the configuration. So if you have a container with, let's say, a background color, the container element would indeed just be a relatively empty box pointing at the widget, which then holds the information about the background color and so on. Now, such elements get created for all widgets. Now, important for stateful widgets, there, you had this createState method, you remember? Like here in new transaction. In the widget itself, which extends stateful widget, you had this createState method, which in the end is called by Flutter to create a new state object based on your state class down there. This split into two classes will soon make more sense. Because when Flutter encounters a stateful widget, it also creates an element, but then it also calls the createState method and creates a state object as well, which is also connected to the element, and it indirectly therefore is of course related to your widget. The important thing here really is, however, that the element has a reference at the widget, which holds all the configuration for that element, and then it also holds a reference to the state object, which is an independent object, not part of the widget or anything like that, but an independent object managed in memory. So these are the elements, but if they're just basically empty boxes pointing at a widget, what is their role? Well, they're not just pointing at a widget. they also point at the rendered box, at the rendered object you see on the screen. Now, whenever Flutter encounters an element which hasn't been rendered to the screen, you could say, it does render it to the screen. And it does so by looking at the widget at which this element also points, which holds all the information you need for painting it to the screen, like a background color, a border, the size, such things. Flutter then paints that box to the screen. If you want to go really deep into the details here, there actually are multiple steps involved here. It has a layouting phase where it derives the available space, the dimensions, and how that should be sized. And then it also has a phase where it basically sets up listeners to tap events and so on. But we can ignore this here. For simplification, let's simply assume that an element which hasn't been rendered to the screen yet is rendered to the screen. So the element then has a pointer at the element on the screen, so at the object on the screen, and at the widget which holds the configuration. And of course, every element has a rendered equivalent, which kind of ends up on the screen. You can see that if you go back to your code, when you open up the Dart Dev Tools. I showed these earlier in the debugging section. In the Dart Dev Tools, you can see your widget tree here on the left. And there, of course, we see all the widgets we use, but the interesting thing is, for example, if you click on a container here, you see that a container internally also uses a constraint box. And then here, you see that render object for that constraint box. So that kind of is what ends up on the screen, or what Flutter uses internally to know what to render on the screen. So to what to hand off to the rendering engine, which is then the core of Flutter and of Dart, which actually paints pixels on the screen. And that's now way too advanced. We'll not focus on how that happens technically, but this is what Flutter does in the end. It renders content on the screen, and it bases that content that should be rendered on your widgets, and the elements are the middleman which connect your widgets, which hold the configuration, and the parts that end up on the screen. Now that's of course all good, but what does this mean for the build method? The build method is called by Flutter whenever your state changes. There are basically two important triggers that can lead to a rebuild. One is when you call setState, like here in the main Dart file when we delete a transaction. Calling setState automatically leads to build being called. To be very precise, what's happening is that calling setState marks this widget, and therefore the element that belongs to the widget, as dirty, so as something changed here. And for the next refresh, which for 60 frames per second happens every 16 milliseconds, 1000 milliseconds divided by 60. So for the next refresh, Flutter will then take the new configuration as created by build into account and update the screen. So setState leads to a screen update, and what it basically does is it triggers the build method. Now when the build method executes, this code simply gets executed like any other Dart code would get executed. And that of course means that if you use our widgets here, which you typically do, like the Cupertino navigation bar here, or the app bar here, or then down here a row, these things here, these calls in the end all of course are widgets, but most importantly, these are all classes. Column here is a Dart class and we're instantiating it here. You absolutely have to remember when working with widgets and all that stuff, that in the end, I of course always call this a widget because it is a widget, but it's also always a Dart class. And that means we can instantiate it like any other Dart class, just as we instantiated transactions based on our transaction class earlier, up here. There I called transaction using the constructor of the transaction class. We're doing the exact same thing down there in the build method for container and column and so on. Now, since the build method runs again, of course, new instances of all these classes are created. So a new widget tree is basically created here with new instances of all these widget classes. And that is not a mistake or an error. This is actually how it should be, because widgets, the widget tree itself, is immutable. That means you can't change the property of an existing widget. You can't say this container should now have a background color of white by simply editing the property of the container. Instead, you can simply override the container, this part of the widget tree, with a brand new container which has the new configuration. And this is enforced by Flutter because it can more efficiently detect changes when an object changes. So when you have a brand new object which has a new address in memory, than when you change a property on an existing object which has the old address in memory. So this is simply a pattern enforced by Flutter. Before we dive deeper into that though, here's one other important note. I mentioned that setState, of course, calls build. The same is true if you use something like media query auth or theme auth. And you even see that here, if you hover over media query, you see that querying the current media query will cause your widget to rebuild automatically whenever the media query data changes. So for example, when you rotate the device, the media query data changes because orientation is information stored in the media query data, and therefore rotating your device automatically also triggers build to run. The same is true if the soft keyboard appears, because you might remember in new transaction that there we refer to the view insets bottom setting here that tells us how much space is occupied by the soft keyboard. So therefore, since this is also part of the media query data, whenever the soft keyboard appears, any widget that refers to media query will automatically get rebuilt. That's the idea here. That all triggers build. So that already was a lot of talking. We now know when build runs, and we know that when build executes, the widget tree, or this part of the widget tree, is recreated. Let's now dig deeper into that. So build is called whenever you call setState, and you learned that build now rebuilds this widget and all its child widgets. And that's really important. If you call setState, only the build method of this widget is called, but then since this code is executed and we have a couple of widgets which we create in that build method, as you learned, new instances of these widgets are created, and whenever a new instance of a widget is created, its constructor and its build method is called as well. So when we call build here in the main Dart file, that means that also all these widgets down here will be created and their build methods will execute. Now, you have room for optimization here, and I'll come back to that, but generally that is what's wanted. That is how it should work. The idea here, of course, is that the configuration, because remember, the widget tree is all about the configuration, changes, and that then leads to a new output on the screen. But how does this actually work then if the widgets are replaced with new instances? Does this mean that the elements and the rendered objects, remember, these are the other two trees, also rebuild? Back to drawing. We had these three trees. We have the widget tree, we have the element tree, and we have the render tree, so to say. Now in the widget tree, we have a stateful widget. So our own stateful widget here. Now that stateful widget, of course, might have a child widget, which means it's using some other widgets in its build method, for example, a container. And that container then also might have a child widget which we nest in there, which is a text widget. And that's a very basic widget tree here, of course. Now, as you learned, when Flutter first encounters this, so when the app starts typically, it will create elements for that. So it will create a new element here for the stateful widget. It will create one for the container, and it will also create one for the text. So these elements are created automatically. Now, as you also learned, it will also render something on the screen. So it will then, once these elements are created and so on, also go ahead and create the actual render objects which control the content on the screen. Now the interesting part happens. In our stateful widget, we call setState. So something changes there. Hence, the build method gets called in the stateful widget here. So here, in this widget, we call the build method because setState was called. Now, what's actually happening here is that, first of all, we have to realize that the state is managed in a separate object, as I showed on the slide earlier. So the state is connected to the element and not directly connected to the widget. So when you call setState, that edits this state object. Now the widget then, once setState is called, is marked as dirty, which means it's basically replaced with a new one. So we get a new my stateful widget, which reflects that new state. So that new state we have stored in that state object here kind of ends up in the new widget. And with end up, I mean it's output there or passed down to the children there or whatever you're doing with your state data. This new myStateful widget replaces the old one, which was removed because it's dirty, it changed. The state object here, however, this one, does not change. It stays here, it's not replaced. It's still the same object as before. So the state object is detached from the widget object. The widget is replaced when the state changes. The state is not replaced. And that's of course important because your state, your data, which changes over time, should be able to change over time. It would be bad if that would be swapped out for a new state object whenever you try to change it, because then changes basically wouldn't be possible. So instead now, we got a new stateful widget, and there the build method is called. And the build method being called, of course, also means that we rebuild this entire widget tree. So for the container, we get a new instance, and for the text, we get a new instance. But what does this now mean for the element and the render tree? Since we have 3 new widget instances, and with this I really mean 3 brand new objects stored in memory. Does this mean that the elements and the render objects here also are replaced? No, it does not mean that. The cool thing is that the elements hold a reference at a widget, and they also, so to say, hold some information on how to identify their related widget. The first important piece of information each element has is it knows its position. So it knows which child elements it has. So it's basically like a skeleton for your widget tree. Your widgets have a certain structure. Your element tree replicates this structure and actively stores that information. And in addition to that, otherwise this first piece of information would be useless, an element knows which kind or which type of widget it was connected to. So this here knows it was connected to the myStateful widget. The second element knows it was connected to the container widget, so to a widget of type container. And this last element here knows it was connected to a widget of type text. So now every element here in the element tree knows which child elements it has, so which connection to other elements it has, and which type of widget held the configuration for the element that should then actively be rendered to the screen. So since that is known, when we get a new stateful widget up there, which replaces the existing one, what Flutter does is it checks in that position of the widget tree or of the element tree, which is kind of the same here. Do I have a myStateful element here? Because I'm getting a new myStateful widget. And if the answer is yes, like it is here, then this means that the element is kept and it simply updates its reference to now point at the new widget here. That's what's happening. The reference of the element is updated. The old reference is cleared because the old widget was cleared. And now the existing element simply points at the new widget. And it then passes this information on to the render object, which is also kept, so that the render object can update in the places where it needs to update. So for example, if the background color is the same, but the text changed, the render object will only re-render the text pixels on the screen, so to say, and not everything. It doesn't lay out itself again, and so on. And this is why Flutter is so efficient. It has this element tree, which is not rebuilt whenever build is called. Only the widget tree is rebuilt, and the element tree can automatically update its references to know if a new configuration is available, and if that is available, it passes that information on to the render objects so that these can re-render on the screen. Now, if you want to learn even more about how Flutter manages all of this internally and which optimizations it puts into place, you find an interesting article attached to this lecture where you can dive way deeper, but this is basically how it works. And this is why calling build or having the build method called does not mean that the entire screen re-renders, because Flutter has a couple of layers to manage that, and calling build, or the build method being called, only means that this widget tree, so that tree of configuration data rebuilt, or parts of that tree rebuilt, and therefore Flutter now checks which parts on the real screen need to be updated. With that deep dive at how Flutter manages all of that, let's see which build methods actually get called for which actions. For that, let's go to the main Dart file, and there in the build method of the my homepage state class, I'll add a print statement where I simply print build my homepage state so that we can see in the log when this method executed. I'll do the same in the transaction list widget in the transaction list Dart file. There in the build method, I'll also run build for transaction list. The same for the chart here. There in the build method, I'll print build chart, and for the chart bar, there in the build method, I also want to print chart bar. You could also add it to the adaptive flat button if you wanted to, but I'll print it for these widgets. Now with that, if you have an emulator up and running and connected, do a full restart here with that green arrow in the top right corner here. And let's see where build now gets called in our app. Before we touch anything, let's already go back here to the debug console. And what we see here is that build gets called in my homepage state, then it gets called in chart, then in the chart bar, and then actually this means that it is called 5 times more in the chart bar. So we would have the same output as we have here, 5 times more, which is why the debug console kind of wraps this together into one log. But we would have 5 times, and overall with this log here, 6 times chart bar being logged. And then the transaction list build method runs. Now let's refine this actually a bit by going to the chart widget here. And there for the constructor, I'll remove the semicolon and actually add a constructor body. You can still use this shortcut with this and then the argument name which matches your property name. But here I will now also print constructor chart so that we also see when this constructor runs. I only did it here for the chart. You can of course do it for other widgets too. So again, time for a restart, and now let's see what happens in the debug console. We see my homepage state gets called, then the constructor of chart gets called, then the build method of chart, and then the build methods of chart bar and transaction list. This output makes a lot of sense, of course, because the main Dart file is our entry point. There we run app with my app when the app launches. My app is a stateless widget, which in the end simply instantiates the my homepage widget there. So my homepage is created here. That creates its state, and when the state is created, the build method in the state runs, and that is why we see my homepage state first. Then this build method executes, and therefore Flutter instantiates all these widgets here, all these Dart classes here, and therefore, since we added our logs to, for example, the chart widgets, we see output regarding that. We're not in landscape mode, so hence we see here that we render a container with the chart, and then we render our transaction list widget. So here chart gets created, an instance of the chart class, which is why the constructor of chart is executed. And then since this all is a widget, Flutter goes ahead and calls the build method in chart. Now inside of chart and its build method, there of course we see that all these chart bars get built in the end. Of course, we have a bunch of other widgets getting built as well, but we didn't add any print statements in there, which is why we see no output for these. But the chart bar here gets created, and of course we create this chart bar 7 times, not 6 times as I said before. Of course we have 1 plus 5 plus 1 output, so 7 times chart bar here, because we have chart bars for 7 days. Now once these chart bars are created, and once this part of the widget tree is done, Flutter actually goes back, because here it isn't done. It now built the chart with all its child widgets. Now the next line is executed. If we're not in landscape mode, this is this line here. And then we build the transaction list widget, which is stored in a variable up here. And there we in the end build our transaction list widget. And therefore, we see build transaction list, because in the transaction list widget, the constructor gets executed. We have no log for that, which is why we don't see that in the log down there. But we have a log in the build method, and that is executed when a new instance of transaction list is created. So this is how build runs when the app starts. Now let's do something. If I open that overlay here, for example, nothing changes here. Nothing rebuilds. Let me clear the debug log with this button so that we can see fresh messages easily. And now let me tab into title here. Without typing anything, you see that now my homepage state actually was rebuilt. On first look, that could be strange because when you tap here into your input field, we certainly don't call set state. But remember that earlier I said that build is not only executed when you call set state, but for example, also in the media query or when the theme changes. Now, the theme hasn't changed, of course, but the media query did. The media query also holds information about the view insets. That's something we take advantage of in new transaction. Here, we're referring to the view insets data stored in the media query to find out how much space is occupied by the soft keyboard so that we can actually move our content up by that space. So since this is part of the media query object changes, and this is a special kind of widget to which I'll come back, which automatically triggers rebuilds of all the widgets that refer to it. And just because that is important, it doesn't care about whether you actually are only interested in the view insets or in something else. Any widget which uses media query off will rebuild no matter which data you then access from there. So this is why the build method of our my app or my homepage state component rebuilds or reruns, because there we are using the media query off object because we need it here for the orientation. Orientation hasn't changed, but as I mentioned, whenever something in the media query changes, everything that depends on media query will rebuild. So that's why build here runs when we open the soft keyboard. And then, of course, as you learned that build runs, this code gets parsed, all these widgets are recreated, new instances are created, and therefore, we also create a new chart, all these new chart bars, and a transaction list. Now, of course, this might sound very inefficient now. Just because media query changed, even though we're not using a feature of media query here that did change, we rebuilt this entire tree. Isn't that a problem? It's not a problem because, for one, as you learned, rebuilding the widget tree is really not that bad. It doesn't mean that Flutter has to rebuild the entire user interface and recalculate everything there. So rebuilding the widget tree is way less expensive, way less problematic than rebuilding everything. And therefore, rebuilding the widget tree is a core mechanism of Flutter and really not bad. But of course, what you can always do in your apps, and what you should do, especially in bigger apps, is that you try to split your codes into widgets such that you have certain features which cause regular rebuilds, like media query changes, only in some widgets and maybe not in your main widget tree, like we have it here, that holds essentially your entire app. For tiny apps like this one, where you only have one page, so to say, only one real section, right? We only have that personal expenses tracker. We have no user profile or anything like that. So for apps that only happen on one screen, it's not that uncommon that your main widget tree changes a lot. But if you have bigger apps, you might consider splitting your app efficiently so that the parts that do change often are confined or contained in their own widgets so that they don't spill over into other widgets. Because, for example, if something would change only in the chart widget, only the build method there would be called, and therefore all these widgets would be recreated, and the chart bar would be recreated. But rebuilds here in the chart would not spill over to our my homepage or my homepage state class here. This build method here would not be called if a child widget of it, like the chart widget, rebuilds. That's just something important. So splitting your apps efficiently is a good idea, but always keep in mind that build calls and the widget tree being rebuilt is generally not problematic and a core functionality of Flutter. And Flutter manages this efficiently to not rebuild the element and the render tree all the time. Even though rebuilds of the widget tree aren't that bad, of course it's never a bad idea to avoid unnecessary widget rebuilds. Because that simply means that even though it's just a configuration tree that changes, Even if we can avoid a change there, we of course save some processing time and therefore can overall improve our application performance. In small apps like this one, not really in a measurable way, to be honest, but especially in bigger apps, every tiny bit of performance improvement can count. And one relatively easy improvement is the usage of so-called const constructors and const widgets. And that's simply something we haven't learned yet, so now's the time to do so. You know final and const already. As you learned earlier in the course, final variables or properties are variables or properties which are created dynamically at runtime, but which then never change. On the other hand, const properties or variables are properties or variables that are holding a certain value, which is already known when the code compiles and which will never change after compilation. Now you can also build so-called const constructors. Now what's a const constructor though? Let's go to our chart bar here. There we have a constructor. Here it is. And what you can do is you can add the const keyword in front of that constructor as well. You can do this if you bind all your arguments here in the constructor to final properties. So for example, if I turn that string into a non-final string here, so if that label is not final, we get an error down there that we can't make this a const constructor for non-final fields. But if you only have final fields which you're targeting, so if you're saying that whenever you're creating an instance of this chart bar class, this instance will be unchangeable because you won't be able to then access this instance with the dot notation and change the label after this object has been created, then you can mark this as const, which means every instance of this object you create is immutable. You can't change it. So what I mean in detail here is that in the chart widget, in the chart class where we create the instance of the chart bar, this here in the end is just the instance of a class. It's an object, right? Of course, an object that's treated and used as a widget by Flutter, but most importantly, it's a normal Dart object, just like if we built an object based on our transaction class. So therefore, as on every object, we can use the dot notation after it was created, so after the closing parentheses of our constructor, to interact with that object. And there, for example, we can access the properties of that object, the label, the spending amount, the spending percentage of total. Now, we don't typically do that on our widget objects because we don't use them like normal objects in Flutter and Dart. Instead, we simply use them to pass them on to the Flutter widget tree. But you could access the label here if you wanted to read the label for this concrete chart bar instance. Now, when the label is marked as final, as it is here, what you would never be able to do is assign a new value to label here with the equal sign. That's simply not possible because it is final. Now that's what I mean with immutable, an immutable object. This object, the chart bar object, the chart bar class, is immutable as soon as it's instantiated because all its properties, so all the things you can access with the dot notation, are marked as final. And then you can turn this, or you can annotate this with const to make it clear that your intention with this class is that every new object that's created based on it is immutable, so it can't be changed. You can only change it by replacing it with a new instance. And if you remember what I said earlier about the widget tree and the element tree and the render tree, I said there that the widget tree is full of immutable objects. All the widgets are immutable. When the build method runs, in the end, it creates a bunch of new instances because it calls the constructors again. So then it replaces the old instances with the new ones. It does not go ahead and take the old widget and only update its label by assigning a new value. Instead, it creates a new widget with a new label passed into the constructor. That's what's happening. So that's why we can use const here. Now, when we have const here, and we do indeed create instance of this widget with compile time constant data, then we can let Flutter know about it. So here we could then, when we use our immutable widget, we could add const in front of it. Now in theory, in Flutter, every stateless widget you build is immutable, and you can add const in front of the constructor of basically every stateless widget you build, because in stateless widgets you always have final unchangeable properties, because you can't use setState in here and update the user interface if you would change a property anyways. So hence, basically all your stateless widgets are theoretically immutable, or are immutable. But you can't create them here with const in front of the constructor, because the data I'm passing here into this concrete object of chartbar is indeed dynamic. It's not known at the point of time of compilation. You see this here if I hover over this. Arguments of a constant creation must be constant expressions. And this is not constants because this value here changes dynamically. Of course, this does not change the object dynamically, but when a new object is created, at the point of time we're writing this code, we don't know which data will end up there. So we can't add const here. Now, why would we have wanted to add const here is of course the important question. You can skip unnecessary widget rebuilds if you mark a widget as const here when using it in the widget tree. And a good example for this would be some text, like in the transaction list widget. There we have this text widget with a text of delete in it. At the point of time we're writing this code, we know exactly how this widget will look like. It will always be just some delete text. This will never change at runtime. Now, still, when the build method here gets called in our main Dart file, and this is called, this will all be rebuilt, and all these widgets are rebuilt. And this includes text widgets like this one, which certainly will never change. In such cases, you can add const in front of the widget, so when you're creating it, because text, which is a built-in widget, if you inspect its code, also has const in front of its constructor, because it extends stateless widget, and as I explained, basically all stateless widgets are immutable because changing properties in there doesn't really make sense. So now what we're telling to Flutter is something important though. And by the way, this is a Dart feature which Flutter takes advantage of, you could say. We're saying this here, this object, will never ever change. We're not assigning any dynamic data here when we're creating it. So when build gets called again, and when Dart goes through this code and creates all these widgets anew, it doesn't have to do it for this one, because we certainly know that this will be the exact same element, the exact same object as it was in the previous widget tree. Other parts of this widget tree might change, but this text certainly won't. Now, by default, Flutter doesn't know that, and it would rebuild this text widget again. Of course, it's not super costly to do so because it only happens in the widget tree, and that is done very efficiently, but still, if we can skip one extra redundant object instantiation, we should do it. So adding const here is a good idea because that tells Dart that the value after it will never change, and that tells Flutter that since this will never change, when it rebuilds the widget tree for this specific widget, it can simply take the old widget which was in the same position. It doesn't need to recreate the object. It's similar for the icon here, for example. Icon also is in the end a class that has a const constructor. And here we're not deriving the icon we want to use dynamically. Instead, it's already known at compilation time, so we can mark this as const as well. It's the same, for example, down there for this icon. It's different for this text here, though. This text here, of course, also uses the text widget, but the data we output as text does change dynamically. So when build gets called again, this could have a different value than when build was called the last time. So here we can't use const, and indeed if we tried, we get an error that in the end we're passing non-constant data to this constructor. But there are a lot of cases where you can use const. For example, also here for edge insets all. Edge insets also is a class, and there it also has const in front of the constructor, so we can add const here too, because this value here, which we use to derive the padding we want to set, is also known at compilation. We never change that value. If you wanted to make this padding overall const, though, this overall widget, you would get an error, because whilst of course the padding value here is constant, a child widget of this padding, and this is part of the constructor of the padding object, is not constant. This holds in the end some other dynamic child widget, this text here, which holds some dynamic content. So the overall padding widget, the padding object here, is not immutable, but a part of it, the object we assign for its padding argument, this would be constant. Now you can certainly identify more opportunities where you could do this. For example, for this sized box widget, which only has one argument with a compilation time constant value. Not for this text here though, because there, the theme, we could change that, so here we can't do it. But in other places in the code, you might still be able to add const. Now obviously, you'll not double the speed of your application with tiny changes like this. But still, it's a good habit to get into and something you might consider in your app. Maybe not whilst you're writing it, because there you typically want to implement new features and you might not think about optimizing the code yet. But when you go over your app, before you publish it, before you finish it up, you might look for opportunities like this, which certainly won't hurt and which might help the performance of your app a little bit. So this was a very thorough look at how Flutter builds its widget tree, how it renders content on the screen, how it updates, and what you can do to make sure that it updates efficiently. And that brings us to writing good code. Now, what is good code? I'd say there are two important pieces that make up good code, two possible definitions. When we speak about writing good code, we could be speaking about writing readable, understandable, or maintainable code. So code which doesn't really impact the performance, neither negatively nor positively, but which is easier to manage for you as a developer. Or we speak about good code that follows certain practices which can help with performance, such as using the const keyword in front of classes or of class constructors, which give you constant objects to avoid unnecessary rebuilds of these widgets in the Flutter widget tree, what I showed you in the last lecture. Now, let's go to the readability point. It might sound unimportant because performance is the most important thing, but actually it's not, because the more readable your code is, the easier it is for you to work on it, to improve your app, and the easier it is for you to write code with little to no errors. Your code should, of course, be understandable to you. That's most important. You have to be able to understand your code so that you can maintain and change it. And when I say understand your code, I mean you should also be able to understand your code in a month or half a year from now. So think about your future self. Your code might be super clear to you right now, but if you have an app and you want to change or edit something in half a year, if you need a day to understand your app code structure again, that's a day lost. So you want to write code which you can quickly get into and quickly understand how pieces are working together. Also, if you're working in a team or if you're sharing your code with others, you should of course also make sure that your code is understandable by others. So you should follow certain common practices and in general write clean and clear code. Now, for performance, there are certain practices, like using const, which can help with app performance. And you should, of course, try to implement these features or these practices. Now, it's important to know, though, or important to keep in mind, that you will always miss certain possible improvements. And that's not automatically resulting in a bad or laggy app. We have very fast mobile devices, and the apps you're building might not be very performance hungry. So even if you can improve the performance, it might simply not make a difference to your users because your app is already pretty quick, even though you're not following every single best practice. Because you will always overlook some optimization opportunity. So checking your app thoroughly is definitely something you should do, and you should be open-minded for new practices and see how you can improve your code. But if you spend days only looking at your code and seeing where you can squeeze out another millisecond, then it might not be worth it if that delays the overall development of your app. Still, of course, it is an important part to keep common patterns in mind and try to build or to write code which also helps with performance. Hence, you should always re-evaluate your code and explore new best practices, even if you have your app already published and you might thereafter have learned about a new pattern which can help with rebuilding or avoiding rebuilding of widgets. And then you might go back and improve your code in places where you can use that. If we have a look at our application here, the code is generally well written, but we have improvement potential. Regarding the performance, only a little bit with more const calls and so on. What we can't avoid here is that we basically always call build method in the main Dart file because we do use the media query in there, and well, it impacts almost everything here, and therefore there's little optimization potential. Though there is some, to be honest. For example, the app bar and the Cupertino navigation bar doesn't really use the media query. So what you could do is you could take all the content that does use the media query and put that into a separate widget, which then only rebuilds when the media query changes, and media query changes wouldn't trigger a rebuild overall here, and hence also rebuild our navigation bars, even though these are not interested in the media query. But that's such a tiny impact here that you could also ignore it, but it would be one potential refactoring. Nonetheless, one thing you can do in this app, however, is, for example, in the transaction list. There we have our list item, this card here with all its content. And it would make sense to take this large chunk of this widget tree and put it into a separate widget. Not really for performance reasons, but to make this code more readable, because it's a relatively large widget. You could certainly leave it that way, but still, it's relatively large, and since this makes such a nice individual widget, I mean, a list item, isn't that a perfect separate widget? It would make sense to put this into a separate widget, so that when you come back to your code, or a fellow developer looks at your code and wants to edit the list item, the developer doesn't have to go through the entire transaction lists widget, but can quickly go to the transaction item file here and start editing in there, and can ignore the transaction list. Now, creating a new widget, thankfully, is really simple. You can simply mark the content which should go into the new widget. So in this case, it's this card here, all the way up to the end of this card. And then use the refactoring tool with that shortcut, and then choose Extract Widget. You're then asked for a name here, and I'll name this transaction item following that Pascal case notation with a capital character at the beginning and for every word inside of the word, and then hit enter. And now in the same file, it will give you a new widget with your name, and then the build method will contain the part you outsourced. Now, in this case here, we still have to do some manual fixes to make sure that we get the right transaction data into this widget, but it's definitely easier than building this from scratch. Now, I will actually cut this widget and add it into a new file, transaction_item.dart, and simply copy my code in here. Now, in here, we then need to import a couple of things. We first of all need the material Dart file. We also use the transaction model, so we will have to import that. And for this, I'll go to the models folder and then import transaction Dart. And I also want to change the code that was generated here. I don't want to get my list of transactions here. Instead, I want to get a single transaction here, because this is created for a single transaction. So I'll rename this to transaction, and the type here will then also just be transaction, not a list of transactions. And in the constructor, I of course say this transaction. This is where I want to store this at. By the way, this also created named arguments, and it added two things, the key and this part after the constructor, which we haven't learned about. For now, let's ignore it. I'll come back to this key thing here later. Other than that, it's a normal constructor with named arguments. Down in the code here, we can now simply refer to transaction, which is this new property I just created, .amount, and so on. So everywhere where we used transaction index, we now use just transaction. I'm also using the date format class here, and that means we also have to import the intel package, and there the intel Dart file. This unlocks the date format class. In the transaction list Dart file, we can therefore get rid of that Intel import because we're not using it here anymore. And there where this transaction item gets created, in case Flutter or this plugin still did it for you, you can remove the new keyword. It's not required. And the data we're forwarding, of course, is not transactions, but transaction. And the value for that is transactions index, because we're still in the list view builder. And hence, we go through all the transactions with the help of their length. And here, for every item that is built, we forward the transaction at that index we're building the item for. Last but not least, since we outsourced transaction item into a new file, you need to import that file here at the top by pointing at transaction item.dart. And with that, we have the exact same application as before. We'll also not have any performance gains, but this code is more readable. We have a shorter transaction list widget, and shorter generally always is better, because if you have less content in a file, it's easier to grasp what's happening in the file. And if you just want to edit the transaction item, you can simply go to the transaction item Dart file and have all the relevant content there. With that, our application still, of course, should work as before. If I add a new value here for today, let's say, that still appears here, and deleting it also still works. So that still works, but this is now one possible improvement that makes sense. Sometimes you don't want to extract something into a new widget, but maybe you want to clean up your widget tree down there. And that can be shown in the main Dart file. There we have a relatively long widget tree, also because we have these checks for if is landscape, is not landscape, is not landscape, is landscape. So essentially you could say the content of our widget tree here, of the my homepage state, basically only depends on the question whether we're in landscape mode or not. We always have the single child scroll view and the column, but what's inside of the column is totally different. In such a case, of course, you could either put the landscape mode into a separate widget and the non-landscape mode in a separate widget, but you could also argue that these are not really separate widgets. They're all part of one and the same widget. It's just a different alignment or a difference regarding how they are displayed. Still, if you want to clean up your widget tree down there, you can add a so-called builder method. With that, I'm not meaning functions or arguments like here on show modal bottom sheets, which also are builder functions here, but I mean a method you add to your own widget, which is only called internally, which returns a widget in the end. That's important. It does not return void. It returns a widget, and you give it a name like build landscape content, and maybe also a second one widget, a widget which builds the portrait content, like this. The idea with these methods is that you can simply call these methods from inside your build method down there, and you simply outsource content you had in your build method down there up into these methods, so that the widget tree that is created is exactly the same. It's exactly the same result, but your code, hopefully, is a bit more readable. So what you can do here is you can grab this row for is landscape, cut it here so that we don't have it here in the build method, and instead return this here for build landscape content. So in build landscape content, I'm returning exactly the same thing I had in my build method down there, but down there, now instead of having all the content here, I just call underscore build landscape content. And important, you need to execute this by calling or by adding parentheses here. Because when Dart parses this, this should be executed. This then returns a widget, and that's the widget which is inserted here into the widget tree. So same result as before, but of course now easier to read. The same here if we don't have landscape mode. So if we are in portrait mode, let's grab that and return this here in build portrait content. Now important, here we rely on the media query and on the app bar, so we should accept both here as input. Now media query here is actually of type media query data. So here we have media query data, media query, which we're getting, and app bar is of type app bar. So here we should accept this argument too. So these are arguments which are now passed to build portrait content. And now again, you use this method to call it down there, like this. And now forward media query and app bar. This is now way more readable. Now, of course, we have two other checks for not is landscape and is landscape. And we might want to merge the content for this into our builder methods we just added. Before we do that, let me first of all point at txListWidget. This is another improvement we're already using. Here, we're outsourcing the content for a widget into a variable. And this makes sense if you need the same widget, the exact same widget with the exact same configuration in different places of your widget tree, often in places which are rendered in an either or condition. That's something we're already doing to avoid code duplication, and that's a good thing. But now back to merging the content we have for portrait mode here into this builder method here, and our landscape content we have here into the builder method here for landscape content. Now you might think that you simply take that transaction list widget, which is for portrait mode, and then you go to your build method for portrait content, and there we are returning the container, so let's add a comma after it and also return this widget here, this variable. Now this has two problems. For one, this variable isn't defined here, so we would have to accept it as an argument. That's certainly something we can do. The more important problem is that you can't return two values. You can always only return one value in a method, in Dart in general, in basically any programming language in general. So this does not work. Of course, you could return a list by wrapping this into square brackets, because then you return one value, a list, and the list then has multiple values. But now a list is not a widget, so that would not work. However, what you can do is, of course, here you could return a list of widgets. Now this would be correct. And now if you also accept this argument here, which is, of course, of type widget, then you can use your builder method down there, forward the txListWidget variable, which we define in the build method, and pass this to build portrait content, which will then indeed return a list of widgets. But now we have a new problem. A list of widgets is not accepted as a widget by Flutter. Of course, here in the children of our column, it wants a list of widgets, of single widgets. It does not want a list of widgets, but that's what we're creating here. This builder method returns a list of widgets and not a single widget. Now, when we call it here, it therefore enters or adds this list of widgets into this list of widgets, and that's not what Flutter wants. It wants a single widget. Now, a good solution here is another modern syntax Dart supports, the so-called spread operator. The spread operator is also available in JavaScript, for example, and it's simply 3 dots. Now this looks strange. You add these 3 dots in front of a list, so in front of square brackets, or like here, in front of a function or a method that returns a list. And of course, build portrait content does return a list. Now what do these 3 dots do with the list in front of which you added? These 3 dots tell Dart that you want to pull all the elements out of that list and merge them as single elements into that surrounding list which we have here, the children list for our column. So now instead of adding a list to a list, we're adding all the elements of this list as single items next to each other in this list. We're flattening the list, so to say. Instead of creating a nested list, we pull out the items and add them as normal items to the outer list. So now we only have a list of widgets because this here, these 3 dots, transform our list of widgets into just widgets, into 2 widgets. Now, of course, you can use the spread operator not just with lists of widgets. You can also use the spread operator with lists of numbers. If you have another scenario where you want to add a list of numbers as single numbers into an outer list, and so on. And with that pattern, we can also, of course, do the same down there for our ternary expression, where we show either our chart or the transaction list. We can simply go up to our builder method for the landscape content here, and also wrap this into square brackets and return a list of widgets here as well. return square brackets here, and add a comma after the closing row, and then add our ternary expression. And here now we also need the media query, the app bar, and the transaction list widget. So these same arguments we needed here for build portrait content. Hence, I'll copy the argument list from there and add it to build landscape content here. With that, in the place where we call build landscape content, we have to pass the same arguments we passed to build portrait content, just like this. And since this now also returns a list of widgets, add 3 dots in front of it to use the spread operator to convert the list of widgets into just widgets that are added to the outer list. And now this if statement down there can be removed. So with that, the advantage is not that we have less code in this file, we just moved the code into a different position, but we have a more readable build method down there now. We have basically just a column down there, and then we can clearly see that we seem to have 2 alternative conditions, and that we call different methods for each condition. We can see that we seem to get back a list where we pull out elements, and if we want to find out what's in a method, well, then we can simply control or command click on it and then change our code for that content in this place here. So it's not helping performance, it's not making the file shorter, it even added a few lines, but it makes our build method down there more readable. So that's why using builder methods, not build, but builder methods that build you parts of your widget tree can be very helpful for improving code readability. They don't have to return lists of widgets. If you only need to return one widget, you can do that too. But you can also return lists of widgets here with the help of the spread operator. With our code improvements out of the way, let's dive back into some internals of Flutter. Though this time internals you can actively take advantage of, or which you will need from time to time. And that's the life cycle of a widget. Now what's that? Now we'll actually have a different life cycle for the different types of widgets we have. For a stateless widget, the life cycle essentially is that it's created, and of course, as you learned, widgets are recreated multiple times when the build method of their parent widget is called, and that means the constructor is executed and then the build method is executed. That's what you already learned. For stateful widgets, we also have the constructor function being called, but then there we also have create state being called to create that state object, and that's now where the interesting part begins. Inside of that state object, you can add an init state method which will be called automatically. So that's a reserved method name for a method that is executed automatically by Flutter when the state object is created for the first time. And remember that the state object is managed independently of the widget, so when the widget is rebuilt, init state will not run again. It only runs when the state is created for the first time. Thereafter, we have the build method which executes. Now you can always call setState to update the widget and rebuild it. And in that case, or when the widget is rebuilt because its parent widget build method was called, in which case all child widgets are rebuilt as you learned, then did update widget executes. So that's another method you can add in your state, actually in the state object, which is triggered whenever the widget that belongs to that state was updated. And then thereafter again build runs. Now, if a widget is destroyed, so if it's removed because you rendered it conditionally and the condition now is false, then dispose is called. So all these special methods, init state, did update widget, dispose, are all methods you can add to your state object, and they run when the state is created, when the attached widget changed, or when the state object is cleared, is removed, which happens when the widget is removed. So not when the widget is rebuilt, so when it's deleted and a new one is added. In that case, the state would stick around. But if the widget is removed and is not rebuilt, because again, it might have been rendered conditionally and the condition now returns false. Let's have a look at this in practice. Back in our code, let's pick a nice widget where we can add these life cycles. And the new transaction widget isn't too bad for that, because it's a widget which also gets removed when we close this modal here. Then when we close this widget will be removed, and therefore this is a good candidate for implementing these different lifecycle methods. So as you learned, you implement them in new transaction state. And to get a full overview of what's happening, let's actually start with the constructor of the widget. So not of the state, but of the widget. So there, we can now print constructor new transaction widget. Now let's also print when create state is called, and for that I'll convert this from a single expression function here into a function with curly braces where we can have more than one expression, because of course I want to create my new transaction state and return it here. But before we do that, I also want to print create state in new transaction widget. And I also have to remove the semicolon after the constructor. So now we have print statements in the widget. Let's now go to the state. There we can add a constructor. We don't need it here, but we can add it, of course. So let's add the constructor by repeating the name of the class, which is underscore new transaction state. And here we can print constructor new transaction state. Now you learned that there is an init state method which you can add. And here my IDE helps me. When I type init, I can hit enter and it adds init state. Override is added because init state is implemented by the state class we're inheriting from, we're extending. And if we add it on our own, we add override to make it clear that this is not a mistake, but that we deliberately want to add our own, which means that the one in the parent class, state, which we're extending, is not called anymore, but our own one is called. And hence here, you also have to do something which you haven't seen before. We're calling super.initState. Super is a keyword in Dart, which refers to the parent class. So we inherit state here, and that means that when the new transaction state is created, a state object is created as well. And super here refers to that parent object, to that state object, basically, and makes sure that we also call init state there, so that not just our own init state function runs, but also the one that was built into state. Now before that is called, however, you can do your own initializations. And often that is, for example, used to make a HTTP request and load some data from a server or load some data from a database, anything like that. It's also something we'll do later in the course once we reach the HTTP module. For now, all I will do here is I will print init state, just like this, so that we can see that this really executes. Now it's also worth pointing out that the official docs now state that you should call superinitState first and therefore put your code after superinitState, not before it. Now it won't make a difference because what happens in superinitState, so in initState of the parent class, is very trivial and only matters for debugging, has no impact when your app runs in production, and you find more details about that in the next lecture. In this course I mostly call my code before superinitState, and that's also what you find in a lot of official examples, which is why I followed this practice, but be aware that the official recommendation now is that you call superinitState first. And that's also the case for other lifecycle hooks I'll show later. When you call super.something, call that first and have your code after that. However, it actually won't make a difference. There is no code running in these super methods that would not work or run differently if you run your code first. That's really important. Now I also mentioned that there is another method, didUpdateWidget. We can add this as well. Now again, this is a method which also exists in the parent class. We override it deliberately, and just as with initState, we have to call the method in the parent class. Important, you get an argument here, and that is the previous widget that was attached to the state. As I mentioned, this gets called when the widget that is attached to the state changes, and then Flutter actually gives you the old widget so that you, for example, could compare it to the new widget. Because remember, you have that special widget property which you can use in your state. It always gives you access to your related widget, to your attached widget that belongs to that state. Widget will now automatically refer to the updated widget. So let's say the widget updated because it received a new argument in case it took any. Then here you could get access to the new widget, and if you wanted to compare it to the old one, Flutter gives you the old one as a convenience feature here as an argument. In my case here, I only want to print didUpdateWidget though to see when this runs. Now, last but not least, the state also can get removed at some point of time, and for that we can add dispose here. Again, we override a built-in method, we have to call it on the parent class, and then here we can print dispose. With that, let's refresh the entire app here and let's see what we get. Clear the debug log so that we can clearly see everything. And now let's open that bottom sheet. It comes up, and if we now go back, we see what happens is that the constructor of the new transaction widget is called, which makes sense because the new transaction widget is part of this modal sheet, and therefore this is created. Then create state is called. That also makes sense because that is what Flutter does for stateful widgets when it creates the widgets. In that state, the constructor is therefore called. Makes sense because we're creating our own instance of our state class here and we're calling the constructor here ourselves. Hence, of course, we see the log here. And then thereafter you see init state is called. That's done by Flutter. And now what you also see here, the constructor of new transaction was called again. Now, that does not happen because we're using a stateful widget here or anything like that. That simply is a behavior Flutter has here for this modal bottom sheet. It does call this builder function here in show modal bottom sheet, this builder function, which returns a new transaction. It does simply call this builder function more than once. Now, the good thing about this, indeed a bit weird behavior, is that it shows us that the constructor of new transaction is called again, because if this builder function here runs again, all these widgets get created again, so a new transaction gets created again. But what we see now also is that create state is not called again, and therefore the constructor of the state and init state is not called again, because, what I mentioned, the state is managed as a separate object, and when the widget rebuilds, the state is not recreated automatically. Instead, it sticks around and simply the reference of the element which manages the state, is updated to point at the new widget. What is called, however, is didUpdate widget. This is called because our widget updated. The connected widget, the new transaction widget, was replaced with a new one because of that duplicate call in show modal bottom sheet. And therefore we get didUpdate widget executed because the widget attached to the state was replaced. And that's why this is a convenient example. Because of this strange show modal bottom sheet behavior, we actually see both init state and didUpdate widget. Now, when I close this by clicking somewhere on the backdrop, you now see show modal bottom sheet really goes into a frenzy and recreates this widget a couple of times, probably because of the animation it's playing, this slide down animation, which also uses a stateful widget behind the scenes, one built into Flutter to update this. It recreates the new transaction widget a couple of times. As you see, this triggers didUpdate widget. But then, in the end, you see dispose is called, because in the end, once the animation finished playing, this widget is gone, and it's not on the screen anymore, and therefore the element and the render object is removed, because that needs to be removed. You don't want to see it on the screen anymore. And hence dispose is called because when the element is cleared, the state object is cleared as well, and therefore removed. Now that is the life cycle of widgets and most importantly of state. Now, when would you use that? As I said, init state is often used for fetching some initial data you need in your app or in a widget of your app. DidUpdate widget is probably used way less often. You could use it if you know something changed in your parent widget and you need to refetch data in your state. So if you're fetching data from a database and you received a new ID in your widget which is attached to the state, and for that ID you want to fetch new data, you could do this here in didUpdate widget with the information that you have in a new ID. And dispose is great for cleaning up data. Let's say you have a listener to a real-time internet connection which sends you new messages because you're building a chat application or anything like that. Then you want to clean up this connection to your server here when your widget is removed, so that you don't have that ongoing connection in memory even though you have no widget anymore. This will lead to strange bugs and also to memory leaks. So cleaning up listeners or live connections, that is something you would often do in dispose. And that's it for the widget lifecycle. For now, we'll not use too many of these methods, but later we'll definitely need init state once we start interacting with web servers. Besides the life cycle of a widget and the state of a widget, the overall app also has a life cycle. It has a couple of different life cycle states. And of course, the important question then always is, when is this state reached? When can you execute code based on that state? For example, you have the inactive state. Inactive means that your app is not even running in background. It's inactive. The user can't see it. It can't receive user input. It's not fully cleared from memory yet, but it's definitely not, well, too active. A state that can be reached on both operating systems is paused, however. This is when the app is not visible and when it's running in background. So when you can reach it through the task manager of your application, for example. This is available on both Android and iOS, and you can react to the app transitioning into that mode in your code. For example, to do some last-minute cleanup, clear some connection to a server, or anything like that. Now, of course, since you have paused, you also have resumed. This state is reached when your app is coming back from the background mode, if it's again visible and again responding to user input. And this is also available both on Android and iOS. So this would be a good place to then again set up a live connection to a server, check whether you want to change something in your app, fetch new data, anything like that. And there also is a suspending state, which is reached when the app is about to be suspended. So when it's almost gone, but still there, but when it's about to be cleared by the operating system and when it's about to be removed from memory. Now, for all these states, it's important that you never have a 100% guarantee that your listeners to these states are executed, especially for suspending and so on. For example, if battery suddenly goes off or a user removes the battery from the phone, then your app might not reach that state because it's not a clean exit as initialized by the operating system, but a hard exit due to some external factor. That's something to keep in mind. Now, in most cases, however, you can listen to these life cycles, and therefore let's do just that. So how can we listen to these app lifecycle events? Let's do it here in the main Dart file on our My Homepage state. There, you can add a so-called mix-in. We haven't used it before. It's basically, it's a bit like a class, and it's a bit like extending a class, but your class is now not based on that class, but it adds a certain feature from that class you're mixing into your class. So you're adding certain properties, certain methods this other class has, without fully inheriting this other class. It has some technical differences. You also only can inherit from one class. So if you want to bring in features from multiple classes, you would use a mix-in. You use a mix-in by adding the with keyword after your class and after all your extensions, or the one class you're extending from possibly, and then the name of the class you want to extend. And here, that's the widgets binding observer class. Widgets binding observer is something you import here and or you add here as a mix-in, and once you did that, you can add a new method, maybe here after our properties. The new method you can add now is did change app lifecycle state. That actually is a method added by the mix-in, and therefore we add override here to make clear that we deliberately override this. You return nothing here, hence you have to add void. And this method receives an argument of type app lifecycle state, which you can give any name you want. And this is the state the app now transitioned to. So this method will be called whenever your lifecycle state changes, whenever the app reaches a new state in lifecycle. Now, here already important, and hence you should always add this mix-in on a state object, on a class extending state. You also want to clear that listener to lifecycle changes when that widget, when that state object is not required anymore. So let's add dispose here with add override, and in there call super dispose and clear listeners to lifecycle changes. Otherwise, you keep that listener up and running even if that state class, that state object should be deleted. Of course, here for our main state that can't happen because when that gets removed, the entire app is shut down. But if you have a bigger app and you add your app lifecycle listeners in just one child widget somewhere down the widget tree of your app, because in that child widget you're interested in changes to the lifecycle of the app. Well, then when that child widget gets removed, you certainly also want to clear your lifecycle listeners to avoid memory leaks. So here in this pose, you clear all listeners you have to the app lifecycle by referring to widgets binding, and then there the instance property, and there you call remove observer this. Now, before you can remove it, however, you also need to set up a listener. So for this method to be triggered, you need to add a listener, and you do this by adding init state. And there you now use widgets binding instance add observer this. So with this line, you're saying, or you're telling Flutter, hey, whenever my lifecycle state changes, I want you to go to a certain observer and call the didChange app lifecycle state method. That's what widgets binding tells Flutter. We then tell Flutter that the observer is this, so this class itself, and therefore this class, of course, needs to have a didChange app lifecycle state. With that now available, this will get triggered whenever the app lifecycle changes, and as explained, we have to clear our listener, we have to clear our observer here to avoid memory leaks when this state object should be removed. And now in this method here, didChange app lifecycle state, you can react to changes in your app lifecycle. And for now, I'll simply print state here so that we can see what the new state is. For that, let's restart the app. Let's maybe even do a full rebuild here. So close the running emulator and restart without debugging so that this gets rebuilt and launched on the emulator or on the real device. And let's see what's happening there, which logs we see. The app restarted, and if we go back to the debug console now, we see no lifecycle states here, right? We see just the build methods running, constructors running, and so on. We see no lifecycle, app lifecycle methods here. Well, that will change if we go back and we press that home screen button here on Android. So we're back on the home screen, but our app is still running. We could access it here through the task manager. Now what you see is that here we entered inactive. So this was briefly entered on Android, but then immediately after that we actually enter paused. So it first gets inactive, but then Android kind of detects, hey, this is actually just paused. It's running in background. And now if I open the task manager and I go back into this application, we see that here is where we were. It briefly goes back into inactive. So basically during this switch, it goes into inactive, but then it enters resume because now it's getting back from paused to running again. Now if I kill the app now by swiping up here in the task manager, we see it enters inactive and paused, and what we don't see here is suspended. So this is not getting printed here. In theory, suspended should be reached here, but since we clear the app here, also the connection, the debugging connection here, is cleared, and hence the suspended state whilst reached might not make it into our console here because we already cleared our listener here to our app. So this all happens in a very short amount of time, and therefore suspended should run. As I mentioned on the slide, you can't always rely on it, but it should run. But here, for example, we don't get our log being printed because we already cleared the connection, the debugging connection to that app, basically at the same point of time suspended would run. But we can clearly see inactive and paused and resumed, which are the most important lifecycle hooks, because you would use that to, as I said, for example, refetch data when it's coming back into foreground or to clear listeners when the app is getting paused. So with these widget and app lifecycles out of the way, let's turn towards something which we've seen a lot, but which I haven't really had a closer look at. In your build methods, you always get this build context argument. Now, what's this build context all about in the end? We also use it, for example, in conjunction with media query or with theming with this of context method. What's the idea behind context? In Flutter, every widget has its own context. So every widget has its own context attached to it, and that's the context you get in the build method. That's why also if you have certain builder methods, like for show modal bottom sheet, the function you pass there, like this one here, actually receives a context. So this function, we're not using it here, but this function also receives a context automatically passed in by Flutter, because builder functions like this also return a new widget in the end, and that widget has its own context. So context is everywhere, and every widget has its own context attached. Now, the context in the end is the element of a widget in the element tree, you could say. It's some meta information about the widget and its location in the widget tree. So context is used internally by Flutter to understand where this widget belongs, and all the contexts of all the widgets, as I said, are basically the elements in the element trees, and therefore these contexts, you could say, know about each other. They know how widgets are related, how they belong together. The contexts build a skeleton of your widget tree. That's how you could think about that. So that context gives you a direct communication channel across your entire widget tree, because all contexts in the end know about each other. They know where in the widget tree they are and which other widgets exist around them, so to say. And that's why, for example, for accessing the theme, or for navigation, or for media queries, you use the context. Because Flutter has a very efficient communication channel behind the scenes for passing data between widgets. We, right now, always pass data between widgets by using their constructor, right? For example, here, when I create a chart, I pass a list of my recent transactions as an argument to the chart constructor, and therefore in the chart widget, we have to define the constructor, accept this argument, store this argument in a property, and then use this property here inside of the chart widget. That is how we pass data between widgets. Now, it's important to know this is the default way of passing data. But if you have a large widget tree, so with a widget that has another widget as a child, which has yet another widget as a child, and so on, then passing data between these widgets can get cumbersome. Here's an example, and we'll learn about a feature called inherited widget that helps us with make that simpler. So here's our setup. We have a relatively large widget tree with our app widget, a products widget, single product and product detail widget, and also a card widget, which is a sibling to the products widget, for example, in a row or in a column. Now, if we need some information that's managed in the state of my app in our product detail widget, then we in the end have to pass that data down through all the widgets all the way down to the product detail widget. And that's what we're currently doing in the app. Now, depending on the size of the app and the layers of widgets you have, this may or may not be a problem. For general data like what's our core theme, which is set up right at the start of our app, or what are the device dimensions, what's the device orientation, which also is managed by Flutter basically when we create the app, so therefore on the level of our root widget in the app. If we have such data that is possibly used by any widget in the tree and therefore would have to be passed down through many layers of widgets, then using arguments and manually passing down theme data and media query data would be really cumbersome. Hence, Flutter gives us a special widget, the inherited widget. We never used that, but media query and theme uses that behind the scenes. And you get a direct tunnel to the inherited widget and to data managed in there with the help of context, because the contexts know about the general structure of your widget tree, and therefore they can directly access any other widget without passing data through arguments. That's what's happening here in the main Dart file, for example, when we use media query of context. In the end, we tell Flutter we want to get access to our media query data. That media query data happens to be used at the top of our app in the end when we create the material app, you could say. The same for the theme, for example. And instead of manually passing down our theme data object here with the constructor of my homepage app and so on, and then to any other child widget as well. And the same for media query data, which is totally managed behind the scenes. Instead of passing that through constructors, the context object has all the information Flutter needs to find out where our widget is positioned in the widget tree and how it gets to the topmost widget. And then it uses this inherited widget feature, which we won't dive too deep into right now, to get that general theme or media query data. So context holds information about the position of the widget in the overall widget tree, and it is really useful to Flutter because it allows Flutter to establish a direct communication channel behind the scenes to exchange data between maybe at the top of our widget tree or in a certain widget in general in our widget tree, and a totally different widget in our widget tree, which might be a couple of layers of widgets down. We'll actually also take advantage of this idea of passing data behind the scenes in the state management section of this course, where I will show you a convenient alternative to passing data via constructors of widgets. For the moment, we'll stick to that we pass data through constructor approach, but later, as I said, I will show you an alternative which is really good for bigger apps with multiple pages, which we don't really have yet. Hence, for now, our approach is fine, but it's important to understand what the general role of context is. We're almost done with this section. Now I want to come back to something I mentioned earlier. In the transaction item widget, in the transaction item Dart file, we have this strange key thing and this strange syntax here after our constructor. What's this all about? Before I dive into this strange after constructor syntax, let's understand what keys are. Every widget in Flutter can have a key. Now, thus far, all the widgets we created manually don't accept a key argument here as in their constructor. And the reason for this is that most of your widgets don't need a key, especially stateless widgets, so you don't have to accept this argument. But there are certain scenarios where a key is a must-have, and I want to show you an example. Our transaction items here actually do accept a key, but for now we're not using it, and I will show you how to use it in a second. So our transaction items here render these cards, and these are the cards we're using here with our list view builder. Now let's say our transaction item would not be a stateless widget, but a stateful widget. So I'll convert it to a stateful widget with the help of the refactoring tool here. And then here in the transaction item state, I'll use initState to set some dynamic data for this widget which is created, so for every list item separately, when this list item is added. Let's say we want to change the background color of our circle avatar, and every new list item should get a random color there. For that, here in initState, I'll create a new const available colors, const and not final, because I'll really assign some values which will not change at runtime. And their choices are colors red, colors black, and maybe colors blue. So these are the three, and maybe colors purple. These are the three colors I want to use as a background for the circle avatar. The four colors I want to use as a background for my circle avatar. Now in this state here, I'll of course add a new property of type color, which is the chosen BG background color. And I want to assign this here in initState. So here I'll set BG color equal to available colors. And now I want to select a random, whoops, that should be available. And now I want to select a random element there. So not hard code 0 or 1, but calculate a random index number. For that, we can use a package provided by Flutter. We can just add random here, and then add an import here at the top, not Flutter, Dart, excuse me, the Dart math package. So you add this at the very top, because as I mentioned earlier, the convention is to first have your Dart imports, then your third-party package imports, and then your custom file imports. So we add Dart math, and that gives us a random class which we can instantiate. And on that random object we then have, we can call nextInt to generate a new integer number, and we enter the max number we want to generate. And it always starts at 0. So here the maximum is 4, and the maximum is excluded, so it will generate a number which is either 0, 1, 2, or 3. And that is then what we use as an integer to get a random color. So now every list item receives its new random color. Side note, you don't wrap background color here in init state into set state, because init state is called before build is executed. So build will take into account any changes you made here, and therefore you shouldn't call set state in here, but just update any properties just like this, because build runs after that anyways. So here I'm setting my background color, and now every transaction receives a new background color. So now with the background color stored, we need to assign this in the circle avatar. There we can set background color to BG color, and now it will use our randomly generated background color. So let's save this and go back, and let's add a couple of transactions now, like test 11, which happened today, let's say. Okay, I generated a purple background color. Test 2 with this amount here, happened maybe yesterday, and I have a blue one. And now watch what happens when I delete the purple item. So I'm deleting test with $11 and a purple background. So once I'm done deleting this, what we should see is test 2 with $22 and the blue background, right? The purple background should be gone because I'm deleting the whole element. If I click the trash bin here though, you see test 2 is kept and the value is correct, but the background color is still the old one. It's still the purple one, but test 2 had a blue background. So the one with the purple background should have been deleted, and the one with the blue background should be the only remaining element. Now the data is correct. Test 1 was deleted with an amount of $11, but somehow we took the wrong list element. We took the wrong background color. So what's happening here? Time to draw again. Remember that we had our widget tree and we had our element tree and also our render tree, but we can ignore this for now. Now in our widget tree we have our list builder, and in there we have the list items that are created, right? Now in the element tree, a new element is created for every widget, as you learned. You also learned that the state for stateful widgets is created as a separate object and attached or referenced to or by the element. So the state for this list item here and the state object for the second list item, that is connected to our elements. And the elements also, of course, point at our widgets here, as you learned. Now, what happens when we delete a widget? Let's say we deleted this list item here. So therefore, this widget indeed was removed. The state here, however, was not immediately removed. Now, I told you that when a widget is removed permanently from the widget tree, its state also is deleted. And we certainly deleted this widget permanently. But the state is only deleted after Flutter determined that this element here is not needed anymore because the state is attached to the element, not to the widget itself. So let's see how Flutter checks whether this element is still needed. Remember that it holds some information in each element. It holds information about the child elements of each element, so this connection in the end, and it holds information about the type of widget. So if we have the list view here, and then this widget here is a list item, and this widget here is a list item, then the data it's stored in the element is not just its relation to other elements, but also that this element belongs to a list view, and this element here belongs to an item, and this element here belongs to an item. Now, when Flutter rebuilds the widget tree, it also checks the element tree and sees if it needs to change something, which in the end then leads to a change on the screen. It goes through that tree from top to bottom. And then it first checks the list view. The list view element is here. Is there still a list view widget on the same level? And Yes, that is the case. We still have a list view here, we have a list view here. So it goes to the next layer, and it sees, I have an item here. Is there still an item on the same level? Well, of course, this item here was deleted, but that simply means that this item here goes up, right? It's a list, so this item, the second item, simply is now the first and the only item in the list. So actually, Flutter answers this question with a yes, because it still finds an item here on the same level this old item was at. And that's why the state is not deleted, because it still finds a widget that belongs to this element here. We still have an item widget here, this one, and it simply updates the reference. Well, and then it checks this last element here, and of course now, since this item here moved up, it no longer finds a fitting widget, and therefore it deletes this item in this state. This is what Flutter does now. The problem with all of that, of course, is that this state here, for the second element, for the first and only item element here, this state is kept around because Flutter determined that this item here still had a matching widget, this widget down there. But of course, this state previously belonged to the now deleted item, and for example, in our case, stored the background color of the circle avatar. So we dropped the wrong state. This state was dropped, but that's wrong. We should have dropped this yellow state here, this one, but we didn't. So we need some way of telling Flutter that actually items are not just identified by type, but also by something else, so that when we remove one item, Flutter doesn't think that it should keep this element here, this one, around just because the type is the same as the type it now finds on the widget there, but it also should check, is it the same, really the same item, not just the same type, but really the same item with the same data that's stored in there. And thankfully, Flutter gives us a tool for passing this extra information to an element. And as you might have guessed, this tool is a key. Keys are really useful in situations like this. So typically when you have a list, and in a list you have stateful widgets. Now unfortunately, there currently is a bug with List View Builder where even with a key you can't fix this issue. So for the moment, for this video here, I'll actually change this here from List View Builder, which of course has the advantage of being very good for very long lists. I'll change this to a list view with the children property and delete that part down there. Where now in children, of course, I want to map my list of transactions into a list of transaction items. And that's something we also did early already. We take our transactions and there we call map. We pass a function to map where we get access to every single transaction, and for every transaction, which is just a data object, we return a new transaction item widget to which we pass tx as a value for the transaction. Now we also have to call toList on this to turn this into a real list, and now children needs a list of widgets, not a list of lists. So either we add the spread operator here, or since there are no other elements in that children list, we simply remove these square brackets and assign our new list of widgets we generate here as a value to children in the list view. So this still gives us a list of transactions, but now in a way where we have no bug in Flutter so that I can show what keys do for us. Now we need that key argument on our custom item. So now we need to accept a key here in the constructor of our own widget. And every widget that's built into Flutter also has such a key. Like here, the card. On that card, we could set a key if that would be our root level widget in our list view. But in our list view here, the root level widget for each item is our custom transaction item widget. And therefore, we need to add a key to our custom transaction item. And therefore, we need to accept a key argument. So you really only need to accept that when your own widget needs to have a key. And you only need to have a key on your widget if it's the topmost item, a stateful widget, and the topmost item in a list or in situations where you have this strange behavior that you get the wrong state attached to your element. So here we then set the key argument, and now set it to what? Flutter has a couple of built-in keys, and attached you find a video that also explains that key idea and the different kinds of keys. One key you could use is the unique key here. The unique key class here is built into Flutter, and it automatically creates a, unique key for every item. So every new item gets its own unique key attached. We pass this here to key, and now this part here comes into play in our transaction item after the constructor, this :super thing. You learned that super refers to the parent class. By calling super like a function, you're instantiating the parent class. Now, normally you don't need to do that because Flutter does it for you automatically. You only need to do it on your own if you want to pass some extra data to the parent class. And typically that one piece of data you might want to pass to your parent class, which always is stateful or stateless widget for your own widget classes, is a possible key you're accepting. Because that keying functionality is of course managed by Flutter behind the scenes. So if you get a key on your widget, you need to forward it to the Flutter base widget so that Flutter knows what to do with that key. Your widget alone doesn't do anything with that argument, right? We're not using that argument anywhere in our class here. So we need to forward this to the parent widget. Now what's this strange syntax? It's just a short notation Dart offers for calling the super constructor. It's called a constructor initializer list. We, to be honest, rarely need it for our own classes here. If you want to learn more about it, you find a link attached where you can learn more about initializer lists. In short, here it also allows you to initialize the parent widget or the parent class by calling its constructor and forwarding data to the parent class. And here, as I said, we need to forward the key so that Flutter knows what to do with the key. Long story short, with all of that, we forward the key, we accept the key, and we set a key here on our transaction item. And we need to set the key here and not on the card in our transaction item or on the list tile in our transaction item, because you need to add the key on the direct child of your list view or of your list you're creating. So not at some nested widget, but the topmost widget you have in your list of elements. And that is our transaction item widget, and therefore here we set the key. Now let's refresh the app and let's see if that fixes the issue. If we go back and we add a new transaction here, test 11 for today, it has a blue background. Then we add test 2, 22, maybe on that day, also has a blue background. Add test 3. And you can already see something in the background here. These colors are randomly changing basically whenever the state of our application changes. And the reason for that is that this unique key is indeed added to every list item and is truly unique, but of course, this is just a constructor of a class, and therefore this is called whenever our list view updates, and that happens whenever setState is called and when our build method reruns. So unique key is not really that great if this rebuilds constantly, because then with every rebuild of the entire list, even if nothing inside of the list changes, but the parent widget changed, you get a new unique key assigned, and therefore Flutter is not able to match up the items and it loses your data. So instead you should use a value key. That is a key where you pass your own identifier. And that, of course, should be a value that is unique to every list item you have. Now here for our transactions, we have an ID, and therefore the ID is the perfect key here. So we use tx.id here as a value key. And now with that, if we refresh this, you will see that this now will work correctly. If I now start adding a transaction again, for today, let's say, and I then add another transaction. Now you can already see it's not changing in the background all the time. And now we have different colors here. And now if I delete the first one, so the red one, of course we should only have test2 with a black background. And indeed, that's what's happening. So now the key fixed it for us. And how is that now working? If I go back to drawing here, this works because we have our widget tree and we have our element tree. And you learned there we have the list view with the list items. And in the element tree, we have our elements that belong to these widgets, right? Like this. Now you learned that identification happens because this knows about the type of widget, and this knows about the type of its connected widget, and this element knows about the type, and the elements also know about each other. And of course, our widgets have certain types. This is the list view, this is the item, and this is the item. But as you learned, matching by item only is not enough because we have similar types here in the list, and hence when we removed one item, matching by type only led to a problem. Now with a key added to the list item here, this key is also stored as an identification criteria. So if the first item has an ID of 1 and the second item here has an ID of 2, then this key is also stored in the element. So besides checking for the type, this now also knows that the first item here, the first element here, belongs to a widget which is of type item and has an ID of 1. And that's true for this widget, but not for the second widget. Hence, now if the first widget gets removed, and of course keep in mind that our state here is also attached to our elements. If that first widget gets removed, now Flutter, when it checks the element tree, finds out that this element here has no matching widget anymore. Because yes, it does find another widget which is of type item, but not with a key of 1. This has a key of 2. And therefore Flutter goes ahead and destroys this element in this state and does not try to reattach this state to this widget. This does not happen because we now have a key as an additional identification criteria. This is what keys do. They simply make it easier for Flutter to identify the connected widget. Now you should really only use keys when you need them though. Don't start using them everywhere on every widget because Flutter by default doesn't need them. The default mechanism of identifying by type works perfect in 99% of all use cases. It's really mostly that list view with stateful children scenario where you need keys. If we had transaction item as a stateless widget, as we had it at the beginning, we also had no problem. We only have a problem if it's a stateful widget that manages its own data internally, and that data can change, of course, and then Flutter might end up in a situation where it can't match up items correctly and attaches state incorrectly. And that is when you need a key. And definitely use a value key with your own custom identifier instead of an automatically calculated unique key, which has problems when your list is rebuilt, because then new unique keys are calculated as well, and therefore matching up doesn't work anymore because, well, the keys are not found. You have new keys for the next build method run. That's it for this module. A lot of content covered, a lot of advanced topics, a lot of behind the scenes stuff, behind the scenes functionalities of Flutter and how it works. Hopefully a module that helps you write clean code and understand how things work internally to optimize your apps, avoid bugs like here with the key and with the list view. But of course, I also know that this module can feel intimidating because you learn so many possible optimizations and things that happen behind the scenes. Therefore, always remember this point which I showed you. Missing a possible improvement doesn't automatically result in a bad or laggy app. And the same is, by the way, true for readability and understandability. You might find code more readable if you have one large widget tree instead of using builder methods and extracting different widgets. And that can absolutely be fine. Your approach should work for you and your team. And of course, you want to improve and optimize performance, and you should therefore keep these patterns in mind. But it's also fine to go through this module in the course and then over your app once you're done with adding the core functionalities, or to simply overlook something the first time you're building your app and simply fix it later. So don't feel overwhelmed. Simply take this knowledge as a useful reference, this module here as a useful reference, and hopefully you understand a bit better what's Flutter doing in which way behind the scenes and what you should pay attention to and what you don't really have to care about.